All right, a 47 microfarad electrolytic capacitor uses aluminum oxide as its dielectric. Typically, it's some oxide. Oxides tend to be good insulators. And the K, the dielectric constant of aluminum oxide is 9.1, right? So this means that what we're going to use for this constant is not that of air or of a vacuum, but it's going to be 9.1 times that, times 8.85 times 10 to the minus 12. So that's the first thing. So let's figure that out. 9.1 times 8.85 e minus 12. That's going to be 8.0535 times 10 to the minus 11th is what we'll use for that, right? Okay, so let's see. So we want to know the D. We're going to solve for D. So our capacitance is 47 times 10 to the minus 6th farads. That's going to be 8.0535 times 10 to the minus 11th. Our area is, what is it? Oh no, 0.0, oh no. That's too hard. Let's see, it's 0.005. I feel like that's right. Because a centimeter would be here. This would be millimeters, right? Times 0.12. Oh, and then we're solving for D. Okay. There we go. I think I'm good. All right. So I'm going to go that guy, this number here, times 0.005 times 0.12. And then I'm going to divide by this number here. Divide by 47 e minus 6. That should be D. I'm getting that D is 1.02 times 10 to the minus 9th meters. And that's awfully small. I don't know if that's possible. Okay. Here's why, is because atoms, a hydrogen atom is basically 1 times 10 to the minus 10th meters in radius, right? So, we're getting down there to the atomic level. Maybe one layer of oxygen atoms might be that thick. I just don't know. All right.